Page 3, hitting the home stretch here, ladies and gentlemen. Testing for symmetry. Well, x-axis symmetry, we just plug in negative y. Y-axis, we plug in negative x. The origin, we negate x and we negate y. And y equals x, we switch x and y. And look at that, a little typo here. That should be the y equals x line. That should be correct on your papers and not on mine. Alright, so part A. If I negate y, I get negative y plus equals x cubed plus x. Not the same. No go. I'm going to run across and do all the a's at once here. Negative y equals the absolute value of x plus negative y squared. Well, negative y squared is the same as positive y squared, but negative y is not the same as y. Out. And x squared minus negative y squared equals 1. Hey, negative y is the same. Negative y squared is the same as y being squared. We got a winner here. And now let's look at the y-axis symmetry where I'm going to negate my x's. So y equals negative x cubed minus x. Notice I did not put parentheses around here because cubing a negative is negative. So putting parentheses does not affect it. Negative 2 cubed in parentheses or negative 2 cubed out of parentheses are both negative 8. Either way, this is not going to work because we have two negatives instead of two positives. Here, y equals a negative x plus a y squared. Since my negative x is in absolute values, that is equivalent to the absolute value of a positive x. That one does work. And here, this will also work because negative x squared is the same as a positive x squared. So far, 2 for 2 over here. Origin, I'm going to negate them both now. So negative y equals negative x cubed minus x. Well, that's off by a factor of a negative. If I multiply this entire equation by negative 1, I get right back to where I was. So the two sides are, in fact, equal. Here I'm going to negate them both. Negative y equals the absolute value of negative x plus negative y squared. Unfortunately, this does not work. While the right side remains the same, the left side does not. And here, this again will work if I negate both of these guys. Since I'm squaring them both, we're good. And finally, switching x and y. I hope it's pretty clear that this one will not be the same. Likewise here, x equals absolute value of y plus x squared, not the same. And here again, close, but not quite. X squared minus y squared is different than y squared minus x squared. And now we're on to the sketching. Well, I'm doing the negative absolute value of x. Absolute value of x makes everything positive, so negative absolute value should make everything negative. So I'm actually going to flip the positive stuff over the x-axis. So a little blurry here. The 3, and that's looks like a negative 6 there. If I count right, 1, 2, 3, 4, 5, 6. Negative 6. 1, 2, 3, 6. It's going to go down here to negative 3. 0, of course, will remain the same. Then I come in here. 0 is still the same. This negative stuff is still the same. This goes right up through there, but then this piece drops down, and that piece drops down, and this will remain the same. Where am I at? 1, 2, 3, 4, 5. So I am here at 7, 5 it appears. There we go, and if I can draw straight lines, we should be good now. I just said straight lines. Did you know that all lines are straight? So if I can draw a line, I should be good. Saying straight line is not only being redundant, but is also repeating yourself. Now here's another interesting, that 0 is still there too. So here's my graph. And that is lovely right there. Alright, so let's look up here, f of x plus 1 minus 3. So I'm going to take my entire graph and move it left 3. Now this is going to be a little interesting because I cannot see them both right now. So I'm going to change this around a little bit and see if I can do this with I can't have it that small. Let's go a little bit bigger. 150 is too much. Let's see if I can go 125 and see if I can squeeze everything on. That's going to be helpful. That's better there. All right. Whoops. There we go. Okay, so I'm going to go left 1 and down 3. So this guy is over against the edge and down 3. This guy is over to the -7 and at the axis. And it runs across. And this guy drops down to -3 and over there. So it's -3, -3 it looks like. This guy bumps over to 1, -1. And then the -2 moves down to a -5. Left 1, down 3, so we're at the point 3, -2. Goes across 2. And this guy here moves from 7 to 6, and from -6 to -9, it looks -5 to -8. So to +6, sorry, and it looks like -8 is down here. And it runs across 2. So we're just playing connected dots at this point. Whoa, little curve. Wow. Well, I didn't lift my pen at all, so I got to start that whole thing over. I'm going to lift in case I make a mistake. That hit the dot there, by the way. There, that was a little better. And let's take a quick glance. Does that look like the same shape and everything? It does. It looks like everything's moved down 3 and to the left 1. Now this one, we are going to flip it over the y-axis because I'm negating everything. And then double it. So this guy right here, which is -5, we're all the way over here at 9. It's going to become -9. And if I double -5, I get -10. And that goes over to here. This point here, which is 1, 2, 3, 4, 5, which is 6. 6, 1 will come over to -6. 1 doubled is 2. And that looks like it goes on for a span of 2. This point here, the -2 will become -2, -4. This point here, -2, 0, will become 2, 0. This point here, which is -3, 3, becomes +3 and 6. That goes over for a span of 3. And this guy here, -9, 0, becomes 9, 0. So, long connector here. That's bad. There we go. We're going on an angle, and we got it. Zoom, 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 zoom. So it should be a very similar shape, but everything should be a little bit stretched, vertically taller, if you will. Well, that is the review for Chapter 4. I hope you got a little bit of information out of that. I hope your review is already correct, and you just simply checked your answers. Good luck on the test, and have a nice day.